Okay, welcome back. So I'm going to start off the second video lecture about your first radio with something that you should memorize. So the test, the technician class test, it might ask you a question something like this. Which of these devices, blah, 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 list of devices, which of these devices increases output power from a radio? So like which of these devices increases output power of your radio signal? And in order for you to be prepared for the test, I will tell you right now an RF power amplifier is what increases power output. And if you think about it, it's sort of self-explanatory. An RF power amplifier amplifies the RF power, duh. So amplifies and increases, both of those words mean the same thing. So this should make sense. So if the test asks you what increases or what amplifies power output, you'll know it's a power amplifier because it amplifies, it increases the power coming out of a radio. So the next thing we'll learn about is deviation, and we're going to spend a lot of time on this topic. So deviation. What is deviation? What does that mean, especially in context of ham radio? So usually when we say something deviates, we mean that it sort of goes off of its original path towards some other direction. Like if you say you're deviating off of a path, that means you kind of go off the path a little. You don't follow the path. If you're like this squiggly guy over here, you deviate from standing up in a straight line, and so does your hair. So deviation with FM signals is a little similar. So with FM, the audio that you send into the ham radio microphone, sort of like this microphone up here, the audio you send into the microphone actually causes the frequency of your radio to wiggle around and deviate from the frequency you set it to. So let's look at this diagram up here. This line here, that's called the carrier frequency. And this is basically, this line represents where you set your transmitter to transmit, the frequency that's displayed on the radio dial. But this isn't just, the whole signal isn't just comprised of this. These two lines up here, that's also part of the signal. Because you'll remember the signals on ham radio, FM signals have a lot of bandwidth. They take up a lot of space on the band. So think of this as sort of the edges, I think, of the radio signal. And what happens is when you talk into your microphone, these things will actually deviate a little. They'll kind of wiggle around in order to transmit your voice. And the louder your voice is, the farther these things deviate away from this carrier frequency. So in other words, again, let me explain this a little more just to make sure you understand. These lines over here, they represent the FM signal, and the middle line is the frequency you're transmitting on. So when you speak into the mic, part of the signal over here on the right and left, they deviate away from this middle signal as you're speaking. So if there's silence, they might be still, but if I say hello, then they're gonna deviate a little, like so. So let me erase this. Okay. So they kind of modulate as you're speaking. These two things over here, the edges of the part of the signal, they sort of deviate away from this middle carrier frequency, which is what we call it. So now you'll notice that when this deviation occurs, this is another important thing to notice. When this deviation occurs, the frequencies of these two lines on the left and the right change. See, this line here represents frequencies. So this here is, I don't know, why don't we say this is 146.000 megahertz perhaps, and maybe this is 146.050 megahertz, anything like that. Anyway, you get the idea. The frequency is getting bigger as we go this way. So this line, this black horizontal line, represents frequency. So this modulation, you'll notice when deviation occurs, the frequencies of the lines, two lines on the left and the right, they change. Because as they're going to the left, well, then the frequency is getting smaller. If they're going to the right, the frequency is getting bigger. So the frequency is constantly changing. And this modulation of the frequencies is actually how the FM signal transmits the sound of your voice. So depending on the noise that you're speaking into the microphone, it modulates these frequencies and they deviate away from this middle frequency, this middle line here. And another radio can detect those deviations and be able to tell what your voice is sounding like based on that. And actually, this is why FM is called FM. FM, in case you're wondering, FM stands for frequency modulation. Frequency modulation. Because when you speak, your voice modulates the frequency of your signal through this sort of deviation on the right and left here. And that's how the radio transmits the audio when it's using FM. Now, the amount of deviation that occurs in the FM signal depends on how loud you speak. So if you speak quietly, let me erase this. If you speak quietly, it'll just deviate a little bit like that. But if you speak really loudly, it will deviate like that. You see? See what I mean? Okay, so another word, by the way, another word for volume in ham radio is amplitude. And actually, this is a bit of a simplification, but we'll learn more about amplitude later on. So right now, just think of the word volume whenever you hear amplitude. So what I basically said up here with this deviation is the amplitude, or the volume of your voice, it determines the amount of deviation in an FM signal. Now, I want to make one more note here. If you look carefully at this diagram, you'll notice something. Let me ask you a question. What do you think happens as the deviation in this signal becomes greater and greater? See, the signal does not deviating much here, but the signal over here, it starts to deviate a lot. And the signal's deviating more and more this way and that way. And what's happening as this deviation occurs? What's happening to the signal as this occurs? Well, if you look at it, the signal actually gets wider, because remember, these represent the right and left edge of the signal that you're transmitting from your radio. So if the signal's going out here and all the way out here, your signal suddenly goes from being this wide to being that wide. So your signal's actually getting bigger. Your signal's getting wider. It takes up more bandwidth. And because it's deviating more and more from this middle frequency, which is called the carrier frequency, and just memorize that. It's sort of what carries the whole signal along as it goes through the air. But it's a carrier frequency. That's the frequency your radio is set to. But the more deviation you have, the more bandwidth the signal occupies, as you can see through this diagram. Now, I know that's all really confusing, so if you don't understand this whole thing about deviation and frequency modulation, don't worry. Actually, even this is sort of simplifying everything a little bit, so this might not be a totally accurate explanation, but it's good enough to get you to understand the concepts well enough to pass the test. But even if you don't understand this, don't worry about it. There's just really two things that you need to know for the exam, and those two things are as follows. Number one, the amplitude, or the volume of your voice. The amplitude of your voice determines the amount of deviation. And number two, the more deviation there is, the more bandwidth a signal occupies. So really all you have to do is write those down, even if you don't understand deviation or amplitude or anything like that. If you write these two things down on the test, you'll be okay for the exam. And if you do understand the why behind these two statements, and if you understand everything I said, then that's really great. But if not, don't worry about it too much. The reason I explain it to you anyway is because it's often a good thing to know. And sometimes knowing why something is true, knowing why these statements are true, sometimes that's more helpful in remembering these concepts than just trying to memorize them without understanding them, which is why I explain them to you. Okay, so I know you're probably really tired and exhausted right now, and this stuff is hard to learn. This is a difficult course, I know. But let's just learn one more thing really quickly before you go. So this last topic, it actually doesn't fall directly under the category of your first radio. At least it doesn't seem that way to me. But it didn't fit really in any of the other sections, and the Gordon West Manual actually places it in this section. So let's just get it out of the way now. So many hams actually use computers in their ham radio stations. They'll have a computer, or maybe I have a laptop sitting in my station next to the radio. And computers can be used in ham radio. They're used for a variety of reasons. Sometimes computers are used in ham radio for what we call logging. That is, you make a record of all the contacts you made. You type that in the computer into a big database program on your computer. And computers actually can also be used for sending and receiving Morse code if they're connected to the radio. And they can also send and receive digital modes. And digital modes, that's the type of mode where you can use on ham radio where you talk to other hams using a keyboard, which I talked about briefly. So usually it's using a computer keyboard to do this over ham radio, so hence the need for a computer connected to the radio. You have the keyboard connected to the computer's connected to the radio. So anyway, there are a lot of uses for computers in ham radio. And in fact, there are so many uses for computers in ham radio that usually when the test asks you a question about computers and what computers can do in a ham radio station, usually the answer will be all of these choices are correct because the use of computers is so broad. And that might be a helpful tip to remember for the exam as well. Okay, so that's it for this section on your first radio. So study the section in the Gordon West Manual like usual, take the quiz, and then we'll move on to the next section in the Gordon West Manual, which we're moving away from your first radio, and we're going to look at your first transmission, going solo. So see you then.